Today's lesson is 64% of change. So there's a few vocabulary words that you need to have for sure today, and I'm going to show you what you need to for sure have. You for sure need to know this. Percent of change is how much a number increases or decreases. So something might increase from $10 to $15, and we're going to find out the percent that it went up, or maybe in their case it could also go down. You all should already know that increase means how much something goes up, and decrease means how much something goes down. You don't necessarily need to write this because I hope you know that already off the top of your head. Now, I think one of the biggest questions is when would you ever need to worry about percent increase and decrease? And a lot of the times I would use this in the store. Amazon, if you're an Amazon person, Amazon uses this all the time. And I can show you how they do that. On my Amazon app, and I'm just going to pull out Amazon right here. On my Amazon app, a lot of times if something is on sale, if I look right here, it'll say list price and it's got a number slashed through. And then it says the deal, maybe the new deal for this umbrella is $15.28. It's telling me the percent that it changed. A lot of times it'll have it up here. It'll have it like listed right here. It'll be like, oh, decrease by 52%. So Amazon uses this all the time when they have different percents and when they have different sales and things like that. So that's a time that you would see it if you're an Amazon user. So how do you figure this stuff out? Let's do it. Okay, so how to find percent of change. This is kind of the equation or the formula to find the percent of change. First of all, I'm going to look over here. It says amount of change, and this means the difference. And we all know that difference means subtraction. So you would find the difference of how much it went up or how much it went down. This number here is going to be the original amount of what that started at. So let's say I go and the first day I go shopping, I look at a pair of shoes and my pair of shoes are $80. Okay, and I was like, oh, I'm gonna come back and see if they're on sale next week. And I come back the next week and maybe they went up to $95. Now they're $95. So if I was going to find the difference, first I would find what it changed. How many dollars did it go up? Well, I know my change was $15, so that would go on top. And my original amount is always like the first amount that I saw. What was the first thing that I saw that this was worth? So in this case, $80 would be the original amount. You would take those two things, so this is how it would look. You take those two things, 15 because that's the difference, the original, and it would look like a division problem. You would take 15 divided by 80 on your calculator, and you would get something that looks like this, 0.1875. I'm not done yet because it's really asking me for my percent of change. So now what I have to do with this is I have to make this as a percent. I have to make a percent, and to do that, we talked about this a few days ago. If I have a decimal, what's the rule to make it a percent? The rule to make a decimal per percent is to move the decimal two places to the right. So this would be 18.75%. This means that those shoes went up 18.75% from the first time to the last time that I saw them. So this is how your problems are going to look today. Now, there's a few more things that are involved here, okay? So it's going to ask you increase or decrease, and then it's going to ask you to find the percent of change. So this is what it's going to say. So, and in all my examples, I put money because to me, it makes more sense to figure it out in the aspect of money, of what's happening when you go shopping. So first, maybe I'm going to buy, I don't know, a shirt. It's $57. Holy cow, then it went up to $89. The first thing I'm going to do is I'm going to say, was this an increase or a decrease? Okay, so I know this was an increase. So I know it was an increase. So before my answer, I'm going to have a plus sign. Or before my answer, I might have a minus sign, depending on what happened with my situation. Did it go up or down? So then I'm going to find the percent of change. First thing I'm going to do is I'm going to find the difference. Okay, so I get 2. So it's a difference of $32. That's going to be on my top of my division problem. Now, my next question is, what was the original price that shirt was the first time I saw it? My original price was $57. A good rule of thumb is that if it comes first in the problem, that's the original. Okay, what I'm going to do with those two things, I'm going to divide them. 32 divided by 57, and I get 0.56. It gives me a really terrible decimal. 5, 6, 1, 4, and then it keeps going on and on and on. So to change this to a percent, I will take my decimal and I will move it 2 spaces to the right. And my percent of change would be, it'd be increased about 56 point, let's see, probably 1% if I were going to round it to the nearest tenth. Okay, why don't you try this one? Okay, first thing I'm going to do is it increase or decrease? I know it's a decrease, so my answer is going to start with a negative sign, telling me that's a decrease. Okay, so when I start it with that sign, it tells me if it's an increase or a decrease or not. Then I'm going to say, okay, what's my difference? Oh, my 20 minus 12, my difference was $8. My original was 20, so I'm going to take 8 divided by 20, and that gives me this. So decimal 2 places to the right. So it was a decrease of 40%. Why don't you try a few by yourself? Go ahead and pause it, try a few by yourself, and then I'll start it up again. So the first, I know it was a decrease because I went from 20 to 9. Let's say this is, I don't know, maybe it's a few dish towels or something. I'm going to buy dish towels $20, and oh, I went back and they're $9 now. They're on sale. So 20 to $9, I'm going to find the difference. I know my difference is $11. My original was what I first started at when I first saw them was 20. This is going to turn out nicely. 11 divided by 20 is 0.55. Move my decimal 2 spaces, so it should be 55%. That means it was a decrease of 55%. Okay, same thing here, 25.66 to 29.99. I know it's an increase, so I'm going to start with the plus sign. I'm going to find my difference, 29.99 minus 25.66. My change was $4.33, $4.33. My original, first one. Okay, divide the two. I get about 1.1687. I'm going to stop there. 2 spaces. It's about 16.9% increase. All right, the next thing we need to talk about is percent of error. Percent of errors are very similar to this, just a little different in a situation. So a percent of error is measuring the difference between an estimate, a prediction, or a measurement and the actual value. So for example, if that doesn't mean anything to you, this might. You maybe have done a competition before where you had to guess so many things in a jar. Like maybe in the library during the book fair, you had to guess how many, I don't know, pieces of candy were in the jar. And maybe there were 500 pieces of candy, but you guessed 600. So we're going to find what percent off you were in your guess. You can use it for estimates like this. You can also use it for time estimates. Like, so maybe I estimate it takes me to get here, it takes me 25 minutes to get to school, but yesterday it took me 28 because I had to wait for a train. So we're going to find out what percent off I was. Now it's about the same type of problem, but it's a little different. So this is still the difference. You're going to find the difference in what your estimate was and what it actually was. The difference is down here, and this is the actual value. It's not the original value that you started with. It's what actually happened. So here's an example of this. So if Becky estimates that a charter bus has 34 seats, it actually has 45. What's the percent of error in this estimate? Meaning how much percent was she off in her guess? So first we're going to do is we're going to find the difference. So we're going to take 45 minus 34. She had estimated that was 34, was really 45. She was off, let's see, she was off by 11 seats. Okay, so that's going to be my top number. Now my bottom is going to be the actual. Now it'll say in the problem actually 45 or actually 15 pennies in the jar, whatever. It'll actually say what it was. So 45 is going to be on my bottom. So I'm going to take 11 divided by 45, and I get 0.24444 and 2 decimals places. So she was off about 24.4% in her guess. All right, so here's another example. Maybe somebody estimated that the weight of a baby was going to be 8 pounds, but actually when the baby was born, it was 6.4 pounds. So we're going to find out what the difference was and what the estimate, how much the estimate was off. Okay, so first you're going to find the difference. So 8 minus 6.4. So this person was off about 1.6 pounds. The actual, remember I told you it's going to say that, 6.4. And I'm going to divide those two. 1.6 divided by 6.4 is 0.25. 2 spaces to the right. So this person was off about 25%. Every time that you have an answer today, you have to move your decimal 2 spaces to the right because it wants to know the percent. All right, the last thing I'm just going to leave you with a few to try on your own. Get a few examples in your notebook. This is actually one of the hardest chapters or hardest lessons in the chapter. It's not hard, but everybody forgets how to do it. So the more times you can give yourself some repetition, the better chance you're going to have at remembering how to do this on your test. So I'll give you a few seconds, then I'll start figuring it out. This is about 29.7%, and it was an increase. So I'm going to make sure I have that plus sign there. Okay, this is a decrease, so make sure I find that first, then I'm going to find how much it changed. 15 over 54, because that was my original. I think it's that, yeah. 2 spaces. So about 27.8%. There you go. If you have any questions, let me know. Take some good notes, and I will talk to you tomorrow. Thanks for watching.